Hello, welcome to video number 2. This is 4.1b, where we're going to graph polynomial functions and learn about end behavior. Okay, so we're actually going to start out with the end behavior part because that's going to help us graph. So what end behavior is when we're graphing a polynomial, how does it look? What direction does it go? We used to use some different terminology, so rather than using like positive infinity, negative infinity, which is what we used to use, we're going to talk about x and y either increasing or decreasing. So the first thing that we're going to graph is f of x equals x. What we can do for this is just make a table. So if you plug in, we'll do -1, 0, and +1. So if you plug those in, nothing changes. So this is probably like the first thing you actually ever graphed. So this is just the straight line that goes diagonally. And if we were to continue, it would just go like this. This is also known as, because remember f of x is the same as y, so this is the same thing as graphing y equals x. So how this works is the end behavior, as x increases, so as x goes to the right basically, because we know these numbers get bigger for x as we go to the right, where does y go? Does y get bigger or smaller? Since y is going up at the same rate that x is, y is also increasing. But as x gets smaller, so as we go to the left, y goes down at the same time, so y decreases. I probably should have wrote increases up here rather than increasing. Increases. Okay, so now this one over here, if we were to make a table, an x and y table, notice it's a negative x. So if I do -1, 0, and 1, that's actually going to change all my numbers to be the negative. So negative of -1 is +1, 0, and then -1. And when we graph these, you're going to see how this looks. So -1, 1 is right here, 0, 0 is right here, and 1, -1 is right here. So this basically just makes it the exact opposite graph of what we just had. So let me go ahead and connect my points. You don't need to go crazy with this, but now this time it's different. So as we go to the right, so as x increases, because the numbers get bigger for x as we go to the right, we go down for the y values. So it's the reverse. Y decreases with this one. And then as x decreases, y actually increases. So it's the exact opposite of what we just had. Okay, now let's look at the graphs for f of x equals x squared. And this is the same. Oh, sorry about that. Okay, so this f of x equals x squared is the same as y equals x squared. And when we talked about this, you can make an x and y table out of this. If we did -2, -1, 0, 1, and 2, we would get 4, 1, 0, 1, 4. So you'll see this as soon as we graph it. So -2 is back 2 up 4. -1, 1 is right here, 0, 0, 1, 1. And this is just your standard parabola that we just graphed in the last unit. So this shouldn't look too unfamiliar. Okay, so as x increases, y also increases. So as we go to the right, but this one's interesting because now when you look at it, even when we go to the left, as x gets smaller, y still goes up. So this one is actually increases for both. Now notice the difference between this first set of problems and this one was before we just had x. So if we look at the degree, this is x to the first power. This one is x squared. All right, so let's take a look at how f of x equals -x squared is going to look. Well, it's going to be the exact same table as what we just talked about, except for the fact that we're going to have the negatives. So if we do -2, -1, 0, 1, 2, everything over here is going to be the negative now. So it's -4, -1, 0, -1, -4. So it's actually just going to be the mirrored image of what we were talking about. Oh, no, that's not quite right. So this one opens down now. So as you probably guessed, as x increases, y decreases for this one because it's going down both times. Same for if x decreases. Okay, so now we're gonna keep going here. Now we're looking at x to the third power. So now we're looking at 3. So if we make a table for this one, x and y, this is the same as y equals x cubed. So if I pick -2, -1, 0, 1, and 2. Now if I plug in a -2 in for x cubed, we're actually going to get -8. And if I plug in -1, I get -1, 0, +1, and 2 to the third power is +8. So this one's going to look a little different. You probably haven't graphed this before. So -2, -8 is back to down 8, which is way down here. Where did I go down? I went down one too many. Right there. -1, -1's right there. 0, 1, 1. And then 2, 8 is right there. So when you connect these, you get an interesting shape. Okay. So this one, as x increases, so as we go to the right, it looks like our y values are going up. So this is going to be increases. And then as x decreases, so as it goes to the left, it looks like the y values are going down. So this decreases. So again, just like with the very first example, x and y follow each other. You don't need to have this part here. I'm just showing you which direction. So let's go ahead and look at this other one. So since this is negative, I can go ahead, I can make my table. So if I do -2, -1, 0, 1, 2, now I'm just going to get the negatives of what I had over here. So now I'm going to get +8, +1, 0, -1, -8. When I graph that, -2, 8 is this. I'm just graphing these values. Now I get the exact reverse of this. Okay, so now as I go to the left, y goes up. So as my x values decrease, my y values increase. And as my x values increase, y decreases. So it's the exact opposite. Okay, one more set to go through. So now we're looking at x to the fourth power. So this one's a little bit more involved. So even if we make our table again, so we do -2, -1, 0, 1, and 2. Now if you plug in -2 into x to the fourth, you're going to get +16. You get +1, 0, 1, and +16. So this is very similar to the quadratic when we had x squared. Basically what it is just like a much steeper version or much narrower version of a quadratic, because -216 would be somewhere like way up here. So it's just super, super narrow. But it's still very similar to the quadratic because the end behavior is going to be the same. So as x increases, y increases. And as x decreases, y still increases. It goes up both times, doesn't matter which direction. So as you're probably guessing, for this one, it's going to be the exact opposite. It's going to be super narrow again, but it's going to go down because it's negative x to the fourth. Put that right there. So it's super narrow. And it goes down both times, so it decreases. All right. So there is a purpose to doing all of that. Hopefully you caught on to this idea, but when our exponent is a odd number, we get one of each direction, one that increases, one that decreases. But when our exponent is an even number, they either both increase or both decrease. So when we had 2, the first one was increase, increase, and then when we had a negative, we had decrease, decrease. Same thing when we had x to the 4th. But when our numbers were odd, like 1 and 3 are odd, we get one of each. All right? Okay, so here's our rule. If the degree is even, as a approaches 0, so as x increases or decreases, y increases. If a is less than 0, as x increases or decreases, y decreases. So what this means is like it's going to go up both times. This one, it's going to go down both times. It's dependent on the a value and whether or not a is positive or if a is negative. Okay, if the degree is odd and a is greater than 0, it's going to look like this. So as it goes to the right, it's going to go up, and as it goes to the left, it's going to go down. And then if a is less than 0, it's going to be the reverse. I like to think of it with these shapes because it just kind of gives us the direction that our end behavior should go, especially when we're graphing. Okay. So let's go ahead and practice some of this. So describe the end behavior. We have 3x squared minus 2x cubed plus 4x. So we have to decide what is the highest degree. So if you look at this, this is our highest degree term. So x to the 3rd, and that's an odd number. So the degree, I'm just going to write this off to the side, equals 3. That's odd. And the a value is less than 1 because it's negative 2. So you can go back up to your chart here, just as you're learning this for the first time. The degree is odd, and a is less than 1. So this is going to be what we have for this problem. So as x increases, y decreases. And then as x decreases, it's the opposite, y increases. Okay, so we used this one right here because our a value is less than 1, or less than 0, excuse me, not less than 1. Less than 0, because it was a negative number, and the degree was 3, which is odd. Okay, I'm going to do one more. I'm going to do B with you, and then I want you guys to try C and D and submit those. So B is 2x to the 5th is the highest degree. This time our degree is still odd, but the leading coefficient, this time 2, is greater than 0. So now we actually have to use this one. We have to use this pattern right here. So as x increases, y increases. And as x decreases, y decreases. Okay, so now you're going to try C and D and see how that goes for you. Okay, we have 2 problems left. There's a graph. This one should be graph. I'm going to do this first one. And then you're going to try this one. Try this problem. And you're going to submit. Okay, so when we're graphing these polynomials, first thing we want to do is actually decide the end behavior, just like what we did here. So this is already in standard form. So let's go ahead and look at this right here. The fact that x to the 4th is our leading term because it has the highest degree, and it's a positive, so we know that the degree is even, and the a value is greater than 0. So if we go back up to our chart, that means we're going to have this situation right here. So this is where x increases or decreases. So x increases or decreases, y increases both times. I like this image because this is how our general shape should kind of look. Something like this, where both of the tails, as we like to think of them, are going up. All right, now that we know the end behavior, we're going to make a table to actually get some values because we want to graph this. So x and y. We're going to use the same values every time. So when you do your problem down here, you're going to use these same ones. -2, -1, 0, 1, and 2. All right, and now we have to plug it in each time for these problems. So I'm not going to go through the trial of telling you what to get every time. You're going to have to plug that in and see for yourself. Otherwise, this video is going to take a long time. But the values you should get if you do this correctly are 5, 5, 3, 5, and 17. So let's go ahead and plot these as best we can. So -2, 5 is back 2, up 5. -1, 5 is right here. 0, 3 is right there. Over 1, up 5 is right there. And then 2, 17 is going to go off. So I'm just going to put a point up there to show that it's going to go off. Now I know that this is the general shape of what I want to end with. So as it looks like I'm going up dramatically right here. So I have that. Now I just need to connect these as best I can. So when I graph this part, oh, I apologize. I was looking at the wrong table. You're probably punching in these numbers and questioning how I got this. These are the values I should have gotten. 11, 11, 5, 1, -1, and 23. So let's redo that really quick. My bad. -2 up 11 is going to be off here. -1, 5 is right here. 0, 1 is right here. 1, -1. And then 223 is going to be way up there. So this will look a lot better once we connect these. Now it goes up drastically. Now it's not a perfect comparison with this, but it does match the end behavior. Both of our tails are going up. So that's what that should have looked like. That's my bad. Okay, and that's all that we have to do for the graphing. So you're going to do the same thing down here. Find your end behavior first, then make your table, x and y. You know, we got to use -1 or -2, -1, 0, 1, and 2. Plug those in for x in all of these, and then you're going to get your